Never gonna give you up. I'm never gonna let you go. Never gonna say goodbye. No. Never gonna give you up. Never gonna give, never gonna give. Never gonna give, never gonna give, never gonna give you up. Never gonna give, never gonna give. Never gonna give, never gonna give you up. Never gonna give,
Welcome.
never gonna give, never gonna give you up. Never gonna give.
Let's fix our links real quick. As we let this video start up in. All right. Hey. And more music. All right, so this is our second video today talking about going into science body systems. So I did newsletter 2 earlier and talking about the activities that I had planned with math. A lot of them is digital, so it's very easy to touch base in those. But with science, it's a lot of things that you need to actually be able to hear and to be able to go over. So everybody should have had their Google Classroom login. If you have not gone in, make sure you go into your newsletter. When we're looking at my Google Classroom, this is what we're seeing. Of course, we'll have our drag time, we have our math, and then we have our 2 science classes. If you're in 7th grade, you know about our Dream Keepers. And these are just my, of course, professional learning, my huge district ones, and of course the after school program stuff that I do. So 4th or 7th, you would click, of course, your class. Going through, of course, we've had stuff about virtual, but here we have optional body systems notes. So this was an assignment. So if you click it, in yours, you'll actually see the instructions. So here, so using the PowerPoint provided on Google Classroom, answer the following 2 questions, each in 5 to 6 sentences. So this is more looking at going into body systems. How do we function and what do they do? So like if one went down, what would happen? These would have been the notes that we would have taken in class. Let's see if we can actually pop this out as a PowerPoint. Open a new window. No, it's going to just want us to scroll. So I'm going to open the original file. So it's going to go open up that. I'll go into, let's have everything up here. Resources, biology, and organ system. So we are, of course, still talking about the human body. Let's make sure we get the right one because we do not want an older one. We want the correct version. One from 2017. Because, as always, we always have to update our stuff, and as we go on, we make it better. Alright, so we're going to just go into a slideshow and do it from the beginning. Let's see, that is not how we wanted to do it. So we're going to end that slideshow because it is trying to slideshow on the wrong screen. So, let's see if I put it over here, if it will do the right one. So no, the issue is my multiple screens. So we're just going to end that. Pull this over here. View. Well, we'll just go to the old school way. It is pretty zoomed in, so just going to start here. So we're talking about the human body systems. So our central question, if we would have been doing this in Cornell note format, is how do the systems in my body work together? So your body is made up of so many cells, which those cells then make up tissues, and those tissues make up your organs. Those organs make up the organ systems. And so before we left, we were talking about how all of this is just interconnected and interconnected. So the first system that a lot of us know is our skeletal system. So of course this is our bones. This gives us shape and support. It protects our internal organs, especially our lungs, because our ribs surround those. Our major muscles are attached to the bone and help it move. Blood cells are formed in the center. So your bone marrow, the center of your bone, is where a lot of your blood cells are formed. Those aren't formed by mitosis. They're formed in the bone marrow. They're very special. If you were one of the groups the week before we left, we're doing platelets, white blood cells, red blood cells, you would have saw when you looked at how does that cell start its life, that it came from there. The biggest thing is these store calcium and phosphorus compounds, and that makes your bones hard. It makes it so that if you were to get hit, it doesn't immediately break. You want your bone to be hard, like your teeth. They're made of bone. You don't want them to be soft when you're eating food to just break. Going on, what are joints? So joints are where your two or more bones are come together, and the ligaments then hold that bone together. So like on your fingers, you have multiple little bones, and your ligaments have to run and pull them together. If you get hurt and like you pull your finger, you can even rip those ligaments, and it causes issues like your fingers can't pull down. I can't show it as well. There we go. So my middle finger on this side, I ripped the ligament when I slipped on ice one day. So my right hand, I can't actually pull down my finger all the way. On my left side, it pulls all the way. Ligaments are extremely hard to fix if they get ripped because they're stretchy and it's such a specific thing. I could have tried to go into a hand surgeon, but I doubt we would have gotten any better mobility than I have now. We have two specific kinds of joints. We have immovable, and movable. One allows movement, one does not. So like your cranium, you don't want the pieces of your skull to be moving around. It needs to stay together. Your pelvis, you want those bones to stay together. But there's other ones that you want your bones to be able to move. Your pivot joints are like your elbow and your neck, that it rotates. So like I can rotate my head. I'm pivoting in a circle on my head. Then you have things like ball and socket joints, your hip and your shoulder. So like if you look at the picture on here, so going right here, it has a ball and socket. That's why if your shoulder pops out of place, they can even pop it back. It's extremely painful, but it is a thing. Then we have hinge joints, like your elbows. A hinge, just kind of like a door hinge, swings back, forth, back, forth. And for your elbow, I'm not talking the rotating, because this is the pivot, this is the hinge. There's multiple types of joints, especially in your elbow, that make it do everything you need. Like your knee also goes back, back, forward, back. Then we have gliding joints. So then we have ones that slide over our bones, like your vertebrae. They slide, they move back and forth. It's something like your fingers. These are special joints that are different than the other ones because they have specific movement that we need for them. Going into, of course, a lot of the bone structures. You will not need to memorize all this. I had to have a certain amount memorized in high school, and then in college biology there was more. The main ones that we would have talked about are your cranium, so of course your head. The next one we would have talked about is your clavicle, which is your collarbone right here. We would have then talked about your ribs. The next one going down the left side are your phalanges, are your tips of your fingers and your toes, the movable little parts, your phalanges. Then going on the right side, we would have talked about your mandible, your jaw. Then we would have talked about your femur, the big bone in your thigh. And then we would have talked about the two bones, the tibia and the fibula in your calves. Those would have been the ones that we would have talked about and would be testing and being like, okay, which are these main ones? We talk about a lot of those specifically because those are ones, if like your femur, if it breaks, it's a big deal. And we would have gone into talking about if that breaks, what happens, and some of these will be in interactive labs that will be coming. Going into the next system, our muscular system, of course, what does it do? It helps us move. And the tendons then hold the muscle to the bone. So a lot of times when we're seeing these pictures, we're seeing these cross sections of like what's also on the sides of the muscle. That is your tendons. And we have separate types of muscle. We have voluntary and involuntary. Voluntary is something you control. So like I can control my bicep. I'm pulling it up. I put it down, up, down. I control that. I'm controlling my mouth. I'm controlling those muscles. But there's other muscles that you want to automatically have working. Like your heart, your blood vessels, your stomach muscles. You don't want to have to think, pump blood, pump blood, pump blood, pump blood. Now in addition, tell your blood vessels, release. Because like your blood is pushing, it's pressurized. And then think about your stomach, digest, tense up. That is so much thought process that these things need to be involuntary, something that it happens automatically. There's 3 types of muscle tissue. Within the tissue, we have cardiac tissue. That is found around the heart. Anytime I'm saying cardiac, we're going to be talking about your heart. We then have smooth muscle. This is like your stomach, your blood vessels. It needs to be smooth because things need to flow past it. You do not want your blood getting stuck in your vessels because it's not a smooth muscle. And then, of course, we have our skeletal muscles. These are the ones that your bones are moving. So your biceps, your tricep, the important ones that we've talked about. Then, of course, here is our little person. We would not be going over all of these. And I did not have to learn all these muscle groups until biology in college. So we only would be discussing a couple. And the biggest ones that we would be talking about are your pectorals. Your pectorals are your chest muscles. They start all the way up here and then, of course, go down. You have your bicep and your tricep. We would have been talking about those two. Then we would have talked about your abs, your abdominis, and then your side, your obliques. And then going down to your quadriceps, your thighs. And then, of course, the one that everybody thinks is hilarious, the gluteus maximus, which is your butt. So, in class, we would have been in more of pointing. So, pectoral, obliques, abdominis, bicep, tricep. And it's always the funny one with gluteus maximus. We always just like point at your chair. So, going into the digestive system. So, the digestive system functions to break down your food into forms that your cells can use. Our food, when we eat it, is big to cells. Because remember, when we were in class 2 weeks before we stopped, we talked about on the top of your pen, on the top of your pencil, there's at least 500 cells that could fit there. That is a huge amount. And I could put a whole bunch of dots on my sandwich. And that's way too many. My cells can't take that. So it has to take it and make it down to a cellular level that can be used by your mitochondria to then pull apart and have the ATP. If you forgot about the ATP, go back into our Google Classroom. We still have our cell notes and discussions from those. Parts of the digestive system where your food enters. So, of course, it goes in your mouth. After your mouth, it goes down your esophagus. Remember, you have two tubes. You have your esophagus and your trachea. Food is the esophagus. The air is in the trachea. Then, of course, it goes down to your stomach. From your stomach to your small intestine to large intestine to your anus. Of course, there is more to it, but this is the bare bones, just the basics of how this works. Then, where does food not enter? These are things that create the bile, create your stomach acids, create the things that you need, enzymes, to break down the food. So your liver, your gallbladder, your pancreas, they're part of it, but your food doesn't actually touch it directly. They're indirect parts of it. We have two types of digestion. With that, we have mechanical, which is your food chewed in your mouth, your stomach muscles. It's something that it's actual movement. So me moving my mouth and chewing food, it's mechanical. Chemical is when we're talking about using enzymes and juices and your saliva to break it down to a cellular level. So the first thing you have to do is you have to chew it, you have to break it apart. Your saliva starts breaking it down a little bit, but it really doesn't start really going until your stomach, and then of course through your intestine. It keeps going until it gets all the way out. Alright, of course, here is our picture. We would not be going over all these organs. The biggest one I talk about is you would need to know it's esophagus/trachea. We talk about your stomach on one side, your liver on the other, small intestine in the middle, large intestine around it. That would be the main ones from the digestive system that we are going to remember. Then going on, circulatory system. Function is carry blood. Of course it carries blood. Your blood carries the oxygen, food, and nutrients to all your body parts. It carries in the waste away. It helps fight infections, heal wounds. The biggest thing is in your blood you have white blood cells, red blood cells, platelets, all these things to do all these functions. How it works is your arteries. When we look at a lot of times, our red lines are carrying blood from our heart, so it's taking away. Why is it red? It's red because the oxygen, the blood is rich in oxygen. It's in there, and when oxygen's in there, it's going to look red. When it has it, then it goes all the way through, and goes all the way to like my cell here, and how it gets there is goes through this little capillary. Capillary is like the little side street to the house. So arteries are like the big highways. then you got to get in a little capillary into the neighborhood, then you get to the cell, which is the house, drop the stuff off, pick up their waste, and then you got to go all the way back. The thing is, when you're coming back in the veins, you're no longer oxygen rich, which is why then we see it as blue. So dependent on if you get hurt, if it's blue or red, it can depend on if it's something that's going to bleed more or bleed less, squirt blood or just ooze blood. These are things that happen because of your blood pressure. We have several types of circulation. We have coronary. Coronary is from blood to the heart. So all it is all the blood around the heart, coronary. Then we have our pulmonary. That is just heart to lungs, and back. The thing is, you have it here in your heart. You have the blood. It goes through the lungs, grabs oxygen, comes back to the heart, then gets shot out. Systemic is with everything else. So the thing is, it has to, that's why you have the da-dun, da-dun. You have multiple chambers because it has to be first pumped to the lungs, then pumped back out. Pumped to the lungs, then pumped back out. It has to go through multiple things. We have 4 chambers. The upper chambers, we call those atriums, and the bottom ones, we call them ventricles. And we'll look at the heart in a moment. There's 2 more slides away. Going into what are some facts about our blood. So as I said, we had red blood cells, platelets, and white blood cells. You've talked about these a lot, so I'm not going to go over them more. Plasma is another thing in your blood that carries the nutrients. A lot of times, you'll see this when we're talking about donating blood, or then they're like, oh, you could donate plasma. They're 2 different things. We have 4 different types of blood, A, B, AB, and O. Depending on your blood type, depends on how rare it is. You also hear this negative or positive. It is an Rh antigen. That basically means, do you have this extra protein in your blood? Yes, positive. No, negative. I'm A negative, which means I don't have that extra antigen in my blood. But my husband is A positive, which means he does. So that means if we were to have another baby, I would have to worry about blood type issues. For people who are both positive, there's never an issue. The rarest blood types are O. And why is that? Because they're universal. A universal blood type can be put in everybody. So my dad is O negative, and they always want him, because he can have he can give his blood to O's, he can give his blood to ABs, A's, B's, positive or negative, because he's a negative. So he is one of the rarest. O positive then comes next, and then I believe A negative, which is what I'm at. My mom is also A negative, and she's a huge proponent on donating blood. Recently we haven't been able to do it as much due to our iron levels, but hopefully that will get back under control. So we would have talked about just more of looking at the atriums, left, right. You do not have to know the superior vena cava, the inferior vena cava, and those are not things you learn until college. They're just so that you can see this is the layout and how it gets bumped out and then bumped there. Lymphatic system. This is your lymph nodes. So the easiest lymph nodes I find are here. You feel them a lot of times if you have a cold or if you have strep. This will swell up. Those are your lymph nodes. You also have your tonsils. You'll see those if you open your mouth and you look at the back and you're like, there's your tonsils in the back. They also will swell when you get sick. And then you have your thymus and your brain and your spleen. Your spleen is really important. If you get things like mono, it attacks the spleen and actually can have issues with rupturing. The function of this system is to filter your blood, makes white blood cells, produces them, and destroys worn out blood cells. So once the cells have become the end of life, then of course they become destroyed. The biggest thing that hurts the system is the HIV virus that then of course turns into AIDS when you have a certain amount of T cells that are below. We do have a lot of medical research now for this that helps people extend, but it used to be a lot bigger of a deal that because you wouldn't be able to fight anything off. You could get a cold and pass away. Respiratory. So this is your lungs. A lot of us know this. Our pharynx, larynx, trachea, bronchi, lungs, and I might pronounce this, alveoli. I always say it weird, and I don't know if I said it right. So don't quote me on that one. Function is, of course, taking in oxygen enter the capillaries and gets rid of this. Biggest disease of the system: chronic bronchitis, emphysema, lung cancer, asthma. This is the system that when we're talking about, of course, the virus, that this is the system that gets attacked by it. What is happening is on you in your lungs, within these areas, you have these kind of spongy cells that they create mucus so that it's wet, so that it's taking in, but it's not getting dried out. It's a very good little system there. But the problem is when this virus takes hold, you create too much mucus, and you are literally unable to bring in oxygen because those things are closed off because of all the mucus, which is why they talk about bronchitis and then pneumonia as being an issue. But we don't want to stay there because we, of course, want to continue with the excretory system, which I know is everybody's favorite. Well, you have our kidneys, our skin, our lungs, liver, and large intestine. This is the systems that get rid of waste, toxins that damage our systems, and regulates our fluid levels. So like our kidneys filter our blood, then after it's filtered, it sends that to our bladder, and then of course our bladder to our urethra, and we expel it through urine. You can get kidney disease, and what happens is you get placed on dialysis. Your blood can't filter correctly, and so you have to have a machine help you out. But then we look at this and we're like, oh yeah, we know our kidneys, we know our liver, our intestine. That makes sense. Urine and defecation, poop, of course. But what about our skin? Well, think about it. What does your skin release? Your skin does release sweat. And I know everybody's had that time that it drips and you taste it, and it's like a salty salt because your body is releasing that salt. It's releasing that waste outside of your skin. And that is the largest organ of your body, your skin. All right, going into the nervous system. So we have several parts of the system, but the basic unit is a neuron. This is a type of we have several types of nerve cells. We got like sensories, which are you're sending information, so your touch, all that, your taste. You have your inner neuron, that's the relay. So from your sensory, you have to have some interlays. And then you have your motor neurons. Those are your impulses. So brain. So how does my brain send an impulse to be like, move your hands? Motor neurons. The biggest part of our central nervous system, of course, is our brain and our spinal cord, which is why it's very, very important to keep those protected. So what parts of the brain are specifically into our nervous system? So we're talking about our cerebrum. Our cerebrum is where our thinking takes place. It's our largest part of the brain, our cerebrum. Our cerebellum, that is your muscle movements of balance. So how are you walking and things like that. Then you have, of course, your brain stem that connects to your spinal cord. You have your medulla. Your medulla is the part that does heartbeat, breathing, blood pressure, coughing, sneezing, swallowing, vomiting, those things that happen even if you don't want them to. But of course, the things like your heartbeat, breathing, you want that to happen. You want your blood to be going. This is the part that if you get injured, it's very difficult for this kind of injury to do well, because if it gets above the medulla and your heart just stops beating, it's very difficult, because even with CPR, your body's not choosing to even help out. So even if the person's doing CPR, your body is not helping at all. And I have not seen many recoveries from a above medulla issue. It does result in sometimes brain death. So how can our nervous system be disrupted? So this is something we want to talk about because it's a primary thing that gets brought up with the nervous system of drugs and alcohol. With drugs and alcohol, they act directly on your brainstem. They can change your heart rate, your breathing, your appetite, your sleeping. It disrupts your normal cell function. Alcohol specifically is considered a depressant. It can impair your memory, your thought process, perception, judgment, attention. It kills millions of cells. And the thing is, not all of those can be replaced. Not all of those can be repaired. It's very detrimental. Going into then, we can talk about caffeine. Caffeine is a stimulant. Caffeine will raise your heart rate, can cause tremors, insomnia. And this one's not an illegal one. This one's in your pop, your coffee, your tea. And the thing is, we intake so much. And it's very bad on your heart, because increasing your heart rate drastically multiple times, especially even with like energy drinks, can cause damage and can cause to the point that you can have heart issues and even have a heart attack. Going on to the integumentary. Integumentary is a protection. Forms vitamin D, body temperature. It's basically, it's your skin. When I'm talking about how does it do your body temperature, what happens when you get cold? When you get cold, you get all these little goosebumps. That's because your skin is tensing up and trying to hold in the heat. You'll also notice that your hair will go straight up. When your hair is doing that, it is trapping all the air within your hair and trying to create a field of warm air around you so that you have just this little field. It doesn't, of course, work if it's extremes cold, but it does help with little bits. If you're too hot, you'll sweat. When you sweat, then it'll evaporate. The evaporation, then, of course, removes heat from you. Going into, of course, more about your skin, there's several layers. You have your first layer, the outermost, called your epidermis. This is where new skin cells are produced, where your new skin is. If you get a paper cut and it doesn't bleed, it's just cut your epidermis. In your epidermis, you have your melanin, which is the chemical produced that protects your skin and gives it a color. This is where we would talk about that melanin specifically is from your ancestors, based on what did your ancestors need. So if we were looking at me, we can notice that my melanin, based on what I needed, my ancestors needed more vitamin D. We needed more sun. We needed that light, or we would have had a less dense bone structure, which would have caused issues with, of course, our skeleton. Going into then places that are closer to the equator, which have more sun, they need protection from skin cancer. And so, of course, the melanin changes there, and you have more melanin to, of course, protect against that. Then we go into your second layer called your dermis. This is where your blood vessels, your capillaries, all those things are. So if you get a paper cut and it actually bleeds, you have cut into your dermis. Then, of course, your third layer, everybody's got this, is your fatty layer. It insulates your body, keeps your skin a little warmer. All right, going into our last system, our endocrine system. This is our hormones, and the hormones are chemicals in our bodies that they go around, they control, they regulate. We've talked about these before, that like your stomach releases leptin to tell you when you're hungry. Of course, during puberty, you release certain hormones to have your body get ready. You have certain hormones that are released to tell your body when to grow. These are just like the little marrow carriers of, hey, do this, hey, do this, hey, do this. And we have several of them that are produced through these glands. So which glands are doing what? Well, we have specifically our first one, our thyroid gland. It controls the rate at which food is turned into energy. This is a huge issue, that if people have issues with their thyroid, that they'll start gaining weight or losing weight. And the problem is because they can't control in which the food is turned into energy. That rate is uncontrollable by them and is not a good one. Then we got our pituitary that controls the other glands and your body growth. If you have a pituitary gland issue, you might not grow as tall as you should have been, or you might have an issue with like leg growth. Pineal gland, this is your melatonin. This is the part that helps you go to sleep. Melatonin is the chemical naturally made when you go to sleep in a dark room. This is why some people take melatonin to help. But the thing is, you don't want to start taking too much of it, because your body will start making less and less because they see you're already supplementing it in. It's essentially your body clock. Why some days that you'll still wake up at a normal time. My body, every time, 6 a.m., still wakes up. And I have that immense fear of, oh my gosh, I'm late for school at 6 a.m. It's my pineal gland. It's my body clock is on it. We have our parathyroid gland. This is the amount of calcium in your blood. Our adrenal gland affects the kidneys, and this is your excited, angry, frightened, your fight, flight, or freeze pattern. So a lot of us are going through this. Our adrenal gland has been a little crazy because of the virus thing that we've been talking about. And I'm doing my quotes because we're not supposed to be really talking about it. And a lot of times when you put up videos and you say that specific word, things are being taken down. So I'm not getting into any additional information. But as we take in more of this, our bodies are going through that. What do we do? It can cause our anxiety if our adrenal gland is out of control. Sometimes if our adrenal gland is too sensitive, you can get anxiety from things that would just be naturally happening. And of course, we go to our question that was the overarching of, why are my body systems like a set of dominoes? So going back to our Google Classroom, the specific question I asked was talking about, why could you not function without one of your body systems? So think about, they're dominoes. So if I knock over one, so your lungs, why can't everything else work? If I knock over your liver, stomach, one system, or just one thing, why won't the rest work? You can go ahead and send a message back. You can make a Google Doc. You can make a comment. Please let me know if you got through this and have any questions. I will be going through more next week with the Nearpods and the labs that I will be producing. But that's all for now, and this is our Science Body System Notes. Have a great day.